Hello, greetings everyone from the Indo-German Chamber of Commerce. Very warm welcome to everyone of you to today's webinar, Best Practice for Power Plant Operators, How to Cope with Poor Coal. The webinar today is brought to you along with our knowledge partner, RWE Technology International, GmbH. My name is Indras Ghosh, the Sustainability Lead and Acting Head of Sustainability Projects at the Indo-German Chamber of Commerce. Very nice to meet all of you here today. So today's webinar is important for businesses in India and sustainability in the country. As you already know, India is aggressively seeking to increase its adoption of renewable source of energy. The government has laid out an ambitious target to achieve 450 gigawatts using renewable energy by 2030. At the same time, the country still relies heavily on coal for its energy requirement and to maintain its high economic growth. A recent estimate shows that in India, coal remains a dominant energy source with more than 70% share of total power generation. It is therefore important to have a parallel focus on greater adoption of renewable energy, as well as cleaner and more efficient use of coal for energy generation to support businesses in India and facilitate sustainable economic growth in the country. In the wake of continuing challenges in India, such as shortage of coal supply, tackling of air pollution, and the impact of burning high ash content, we are happy to have today RWE Technology International with us to share their insight in increasing the efficiency of indigenous coal on plant performance and emission management. A short introduction to RWE Group is one of Europe's largest producers of electricity and heat, based in Germany. RWE has deep expertise and a long history with more than 120 years in both mining, engineering, and clean energy technology. Recently, RWE has pledged to become carbon neutral by 2040, investing massively in expanding renewables, consequently phasing out its coal business. With a large portfolio of projects in renewable energy production, RWE is working on several green hydrogen projects as a part of its hydrogen roadmap. RWE is also a global engineering consultancy and the in-house engineering pool within the RWE Group responsible to develop, build, and optimize energy assets. The roots of the company go back more than 55 years to Rheinbraun Bergbau Beratung in 1965. Clients from the mining and the power plant industries across the world have since profited from RWE's wealth of experience as planners, operators. Their more than 350 experts enable industrial, commercial, public sector clients across Europe, the Americas, and Asia Pacific to advance efficiency, safety, and sustainability of their energy projects. Here with us today, it is our pleasure to welcome two prominent experts from RWE, Mr. Axel Meschgbiz and Dr. Nikolaus von Bargen. Mr. Axel Meschgbiz is Senior Expert Power Plant Process at RWE, a Senior Expert in Boiler Design, Combustion, and Operation Optimization of large-scale power plants, and he has more than 30 years of practical experience in the power industry. In particular, he has much experience in development and testing of burner systems, furnace, flue gas cleaning, as well as operational issues at RWE and external plants. He has also in recent years served a number of external consumers with issues of coal combustion, providing recommendation of emission reduction measures, slagging and fouling issues, efficiency improvement, operation and maintenance improvement, as well as plant modification and testing. Dr. Nikolaus von Bargen is a senior consultant coal beneficiation at RWE Technology International. He is an expert in coal mineral resource estimation with additional knowledge in open cast mine design and planning. He has 30 years of experience, beg your pardon, encompasses geological modeling and geostatistical analysis, great estimation of complex mineral and lignite deposits with data mine software package. He has also developed numerous economic models of mineral deposits and conducted training seminars on mine modeling and economic mine evaluation. Dr. von Bargen has contributed to the development of South African SAMREC mineral reporting code and to the Canadian SIM standards on mineral resource and reserves. Warm welcome to the both of you here today. Once again, without further ado, I would give the platform now to Dr. von Bargen. We look forward to an engaging discussion here today.
Okay, thank you, Indras. Ladies and gentlemen, thank you for joining us today. Entitled our presentation, Best Practice for Power Plant Operators, How to Cope with Poor Coal. I'll be holding the first part of the presentation that is more sort of looking at the coal. The second part will be held by my colleague, Axel Meschgbiz, and he will be covering the power plant specific parts. Okay, let's skip to the next slide. The introduction will have, our presentation will be basically consisting of the steps here, introduction and about RWETI, which I'll keep very brief because Indras Ghosh had done a very good introduction here. We go look at the fuels, fuel change in power plants, a little bit at fuel handling and storage, and then we'll I'll hand over to Axel, and he'll be then covering the power plant specific aspects, especially milling, challenges, combustion and furnace, and we'll conclude with a few case studies. Okay, next slide, please. I'll keep that very brief. Generation asset of RWE is actually very broad. It encompasses about any fuel imaginable, plus renewables. A very significant portion of that is actually our own lignite fired power plants, plus hard coal fired power plants. Both of those will be shrinking in, or they will be decommissioned as RWE will be exiting coal. However, to give you still an idea that we do actually have quite a bit of experience in operating these plants and preparing them, designing them and things like that, I'll show the picture of the portfolio as it was beginning of 2019. As I said, nuclear is going to phase out. Hard coal in Germany basically will have phased out at the end of the year, and the phase out of lignite has started, and as things stand now will be completed by 2038. Okay, next slide. Yeah, okay. RWE Technology International is the consultancy arm of RWE Group. We have bundled in there all the engineers, mining engineers and power plant engineers that we have in the group. I don't want to bore you with the statistics where we've been and things like that. The more important thing is that we have continued to have very close contacts to our colleagues in operation, whom we also can co-opt into projects if we want to or need to, or we can just ask them. That sometimes is backup. And the important thing is that thus our perspective is always that of an owner operator or an operator, and we're not just consulting in there and hopefully, you know, are right in that. But we also have direct connection to the operational aspects and the operational details, both in our power plants and also in our mines. Okay, next slide. Okay, now to the actual topic. Let me start out. You know probably all the old adage, there's no such thing as poor weather, only unsuitable clothing. We can reformulate that for power plants and saying there's no such thing as poor coal, only unsuitable power plants, except that it's easier to put on a coat than to change a power plant. Okay, next slide. Fuel change in power plants, it's gone. The question is, why change fuel in a power plant? Next slide, please. When asking this question, we have to differentiate between the situation that the power plant operator is in. There's a big difference between a mine mouth operator and somebody who gets the coal from somewhere else. I call that import in quotation marks because that could be actually from having it shipped from across the sea, or it could be by domestic supply, but being shipped maybe from some more distant mine by train or heavens knows how. For change of why change fuel in a power plant for a mine mouth operator, it's who is normally in a captive relationship with the mine operator. It's usually a mutually captive relationship. They depend on each other. The reason why they have to change is because the coal in the deposit changes. It doesn't change so much, but as the mining progresses, they'll get to different parts of the deposit where the quality changes, and that can actually change quite significantly. Usually for the captive situation, you don't really have much options. You somehow have to make it work. That's it. For the import situation, it's different. Usually the power plant operator has at least potentially more than one supplier. It isn't coupled to one. And for them, usually the question why they need to change is because maybe from their preferred supplier, the better coal is getting exhausted. It could also be that because of market situation or contractual situation, the preferred coal is starting to get too expensive, you know, because of more competition for the coal from other places. They also may be required to comply with new emission limits, which may require a fuel switch to cope with. The ones on the mine mouth situation, if they are hit with the compliance of the new emission limits, they basically have no choice but change the power plant. There's very little they can do. Okay, so somebody who has an import situation, they usually have a few more options when it comes to fuel change. So we'll switch now to the first poll question. The poll question is, what coal supply experience do you have? Okay, so we see that most of you have actually domestic and international import. Some of you are in a mine mouth situation, and then of course some of you maybe not, you're not power plant operators or in there. Okay, let's go on. Okay, when it comes to those that import or get their power plant from their coal from somewhere else, you have the difference between the fuel purchaser and the power plant operator himself. Fuel purchaser usually looks at price, would like to get low price coal. He's usually worried about having undisturbed transport to the plant. That may be not entirely trivial, depending on where the plant is located and where the coal is coming from. Ideally, he would love to have a power plant that basically can consume and any coal, especially the low-priced one. He certainly wouldn't like to have any restrictions to keep track of related to the coal quality, and ideally, he would like to market the byproducts, usually the ash. For the power plant operator, he is in a more cost-thinking mode. He has to worry about how the coal handles and stores. Different coals have different properties there. Very important to him is how they mill and how they fire. In particular, they also he's worried about ignition stability and flame stability, depending on the kind of power plant he has. Then he has to make sure that he complies with all the emission limits. Those are usually several in several directions. And also important thing is some coals damage the power plant if it's not, the power plant wasn't built for it. And one thing the power plant operator is also worried about is to avoid midterm and long-term damage to his plant. Okay, next slide, please. Now let's go on to the fuel itself. In order to assess what the coal or the new coal that the fuel purchaser is proposing to buy is doing to your power plant, you really have to look at the complete analysis. You basically have to approximate analysis, water, ash, volatiles. The calorific value is particularly also have to look at the lower calorific value or net calorific value, not just the gross calorific value. As soon as you've got more than about 10% water in the coal, at the latest 20% water in coal for low rank coals, you definitely need to look at the net calorific value if you don't want to fool yourself. You need to have, of course, look at the elementary analysis. You need to know what the ash is composed of, because that has bearings on how it behaves in the boiler, and what is in there that can cause all sorts of problems later in the flue gas ducts. And of course, it would be good to know the ash fusion trajectory. Your ash doesn't melt at a single temperature, but it sort of starts to soften initially, and then starts to get more sticky and liquid before eventually, when the temperature is very high, it gets really fluid. And that also depends very much on the ash composition. The last thing you want to have is getting into a regime where your coal becomes really sort of sticky goo that will just cover and stick to all your heat exchanger bundles in the power plant. Grindability is also an important issue, because I mean, after all, if the coal eats up your mills, you either have to get more spares, you have to allow for more time for the coal, for maintaining the mills. Yeah, so you need that. It's also important to bear in mind that coals are, there's a wide variety of coals out there, various classifications around. So it's important to know what classification you're using, because as you can see that in different classification systems, the same terms are used meaning different things. For example, subbituminous coal and bituminous coal. For the low rank coals, that covers anything from, let's say, lignite to subbituminous coals, or even some high volatile bituminous coals. Basically, there the main differentiation is by calorific value or moisture content. The two correlate very strongly. Once you get below 10% moisture content, then you differentiate the different coals and coal rank by their volatile content. Especially the fact that when you have coals that are traded around and saying, oh, subbituminous coals, and you're going to higher water contents, they will have severe effects on the calorific value. Okay, next slide. This is showing the whole, just all the coal sort of on a ash-free basis, basically showing moisture content, volatiles, and fixed carbon in there, going all the way from the softest of lignites to the mostly cold anthracites in there. Basically, you can see very nicely that how moisture content and with it the calorific value decreases as you go from lignite B, where you can reach as much as 65 or 70% moisture. That's even more than you have here. And by the time you hit sort of high volatile bituminous A, you've reached about 10% moisture. After that, moisture becomes not a good differentiator anymore, excuse me. The other thing that happens is that the volatile content slowly decreases. In lignite B, you have actually more than 50% volatiles on a dry ash-free basis. That is, you have more volatiles than fixed carbon. That ratio approximately reaches 1:1 when you get into the subbituminous field. And then by the time you go from the progress from high volatile bituminous coal to medium volatile bituminous coal and onto anthracite, you see a strong decrease in volatile, the volatile contribution in your coal. Okay, next slide. When you're looking at imported coals, there is a wide range of coal compositions available from different places, countries. Here we've just shown moisture, ash, sulfur, volatiles, and lower calorific value. Big differences in the composition. Normally, you have the analysis of coal quality done by different independent laboratories, typically at the point of where it gets loaded on ships or on trains, but often it can also be done on where it's landed. The analysis is typically the price is set up following these characteristics: moisture, ash, sulfur, volatiles, and lower calorific value, and of the prices in the supply contract adjust for the coal quality, not just the calorific value, but for example, sulfur content and ash content and things like that. From Indonesia, you get an extremely wide variety of coals. I mean, they're ranging in moisture from about 6, 7, 8, 9% to over 20%, whereas from Russia, Poland, United States, South Africa, you get actually, or Colombia, you get actually a much tighter range of coals there. The same goes for ash content. Indonesia is sort of the odd one out, where you can get very low ash coals going all the way up to very fairly high ash coals, whereas for most others, it tends to be between 10 and 15%. Sulfur, here in that case, USA has a wide variety of sulfur contents. The other countries tend to have lower values. Volatiles, also very big difference. They have they play an important role when it comes to the ignition. And yes, you get a range of lower calorific value. So your buyer will usually have to check on a whole range of aspects whether the coal is actually something that you can burn in your power plant. Okay, next slide. For the lignites, which is the ones, the coals that have actually moisture contents more than about 30% moisture, these typically in a captive mine relationship or captive power plant relationship, there you've got also worldwide an enormous variety of coal compositions. That's even more extreme than on the hard coals. I mean, you have coals that have as much as 65% moisture, low ash, for example, in Australia. On the other hand, you have brown coals in Turkey that go up as high as 50% ash and have only about 20 to 15% moisture. On this diagram, I've shown moisture, the coals as moisture versus ash, and the calorific value sort of as isolines marked with their calorific net calorific value, lower calorific value, in kilojoules per kilogram. India, they tend to be around the range of low ash, between 40 and 50% for navally. Chinese coal lignites tend to be around, let's say, just under 40% moisture and around 10% ash. So that's in that gap that we have there. The most commonly traded hard coals would end up sort of in the lower left-hand corner of this diagram. If you look at this enormous variety of coals, I mean, enormous variety of calorific values and ash contents and moisture contents, things like that, they each can actually have successful power plants running on the deposits. So the technology is there to have to span that. However, a power plant that would be designed to work with, let's say, extreme Turkish high ash, low calorific value coal would have to look quite different than one, let's say, that has a high moisture, low ash coal like you have in Australia or in Germany. Okay, then let's go on to the next slide. I just want to briefly talk about coal upgrading, which is, or as a standalone operation. That's basically something that your coal mine could do. Next slide. For upgrading hard coal, sort of a standalone operation, you basically have effectively two aspects. You can either reduce ash or you can try to reduce moisture. Talking about ash, the classical one is coal washing. It's a well-established technology. Usually the circuits are usually quite complex because you have to have different machines or equipment for different size fractions in there. But usually the thing is arranged in such a way that you've got effectively some like two-stage circuits so that you get both a good separation and a good yield. Separation means how clean you are, how well you can separate between coal and gangue minerals. The yield means how much of your coal that you actually get or put in, how much of that goes out, or how much of the coal that's in there you can actually get out. Coal washing is widely used in India. One of the problems is you've got quite a lot of fines in there, and because of the stages, you have a problem with producers' middlings. That's sort of a medium-high ash product, which is difficult to use or to dispose, because if you dispose it, you've got coal, carbon in your stockpile or in your waste pile, which is undesirable, and it contains a lot of ash, so it's not something that you really want to burn in your power plant. You have also the option of, instead of washing, use coal jigging. There's wet and dry jigging available. Is also established technology, is a bit newer. The nice thing is it doesn't need any heavy media. Well, the separation can be quite well, depends on the coal grain size. Again, any given machine needs to operate or be tuned to for a specific grain size or range. But there are jigs around for lower grain sizes, but the fines is something that you can't really handle there, whereas on the coal washery there are ways of dealing and doing coal separation on the fines. Moisture reduction is really something that's not pre-drying. It's really not a commercially established technology. It's difficult to do. Its problem is it's energetically expensive in the sense that you need to evaporate the water they want to get out. You also, when you're drying coal, you right away have safety issues, dust explosions in there. And quite honestly, if you do a pre-drying, there's some ways of doing that, then it's best actually integrated in the power plant. Next slide, please. Lignite. Upgrading lignites. Basically, the short answer would be forget it. When it comes to reducing ash, coal washing is basically not possible. The reason for that is the lignite will just disintegrate into a slush when you actually run it through water. Often the mineral is also tightly bound in the coal structure itself, so it's very difficult to separate the two or liberate the gangue unless you had, and even in let's say zebra coals that exist, where you have thin layers of coal interbedded with thin layers of gangue. The material tends to be sticky, and so it doesn't like, it's very difficult to achieve separation. Really, when it comes to reducing ash, the only option you have is blending it with better lignite. Moisture reduction, pre-drying, again, there is no established commercial technology. We do have one for pre-drying it at RWE, but it has its own aspects to it. The problem here is that with lignites, with the enormous amount of water in them and the amount of water that you need to get out and evaporate out, it becomes very difficult. First of all, you have to expend a lot of energy to dry it. And the second thing is it's very difficult to get the heat in that you need for evaporating the water to dry it. It's very difficult to get the steam out. While that has been solved, and we have one plant that can do it in RWE, but the problem is the product itself is very prone to self-ignition, that all lignites do that. And transport of dry lignite is only possible in special vehicles, silo trucks, silo rail cars. There is no ships around with which you could transport dry lignite. So that's pre-drying is not really an option for lignite either. Okay, let's go on to the next poll question. Next slide, please. Okay, so there's some of you actually operate their own coal washeries or through their suppliers. Okay, let's go on to fuel handling and storage. The next slide, please. The important thing is that coals which tend to get hot during shipment should be avoided for the transport. Many coals will actually self-heat and continue to heat up in the stockpile of the silo. Whereas the same applies actually in storage as well. The coal silos are actually a problem for the when there's air getting through there. While they do have the advantage of being able to blend different coals to some extent, they protect the coal against sun and rain. The coal yards, they're better for blending the coals, but there is dust emission is a big problem. In all cases, for handling, you need a fuel storage solution, fuel management system in order to keep track of what you're doing or what you're mixing and blending. There's some subbituminous coals tend to self-ignition. You have to monitor their temperature. With lignites, you will have to do it in any case because they will self-ignite after some time. Given the time, I'll skip over the aspects of some of the handling aspects, and I think I'll rather switch directly to my colleague, Axel Meschgbiz, who will be talking to the impact of the fuel on the power plant. That will be slide 26. So if you kindly skip forward, then I'll close here and hand over to my colleague.
Okay, so thank you, Nikolaus, for your presentation. So I will continue based on the information that Nikolaus gave to you. I hope everyone can understand me. So we go to the next slide. Actually, I have to say there is a small delay to transmit the transparency on my PC. Just sometimes there's a delay. Actually, it is essential for the power plant to know which kind of fuel is coming in, and every power plant will be designed based on fuel information, and the fuel makes the whole history of the power plant. So here are some major effects on the power plant listed, which is caused by the coal quality. For example, calorific values have a large impact of logistic, block performance, heat absorption, flue gas exit temperature, and so on. Next slide, I have made for you a matrix that you can have a look on it for future if you are planning a fuel switch or using another coal, which component will have which effect on your power plant that you maybe talk internally or with the manufacturer or supplier to modify this part of the plant. As you see, the most impact is on the combustion and firing. There are many aspects because the flue gas volume will change, and some impurities in the coal cause problems, which cause falling and slagging, and also the heat release in the combustion will transfer to some areas which is not as designed. So you have to make some adjustment at your power plant, otherwise you run into problems. And next slide, I show you, as Nikolaus said, there's no bad coal. It must be only the right solution for this, let's say, coal or fuel. I show you some different type of combustions. For very difficult fuels are the stoker firing, and also for the medium difficult fuels are the CFB combustion recommended, and the PF boiler has the highest efficiency and but is quite sensitive to fuel change and also needs a careful operation. So as there are other combustion like cyclone and retort furnace and rotary furnace that are very special for some special devices. In the next slide, I will ask you to fill the poll. You can make multiple choices. And what is your plant experience background do you have? That is important to continue this presentation. So I expect that most of you have hard coal. Yeah, okay, my expectation was quite right, but there is a higher percentage and with lignite, what is also in India quite often. So, okay, so thank you. To the next slide, please. Yeah, please next. So I expected this answer, so I make a comparison between the lignite and hard coal. The lignite has, due to the high moisture, let's say the green bulk shown, a much more higher volume. Therefore, these plants with lignite, they are much more higher and bigger than bituminous coal. No? And also with the high moisture, you need another technique for the milling. That is a beta fan mill that is established actually. And if you change your hard coal to subbituminous coal, you are going more and more direction to lignite. So usually the water will increase and ash will increase, and also the volatiles will be getting higher, so that the combustion will be shifted. So it's to know what if you plan a new plant, that is important to look at that. And if you trying to change the fuel, so there are some aspects that you have to look on it. So please, next slide. So the impact of milling is an example that I want to show you. The most of the power plants that they are changing from bituminous to subbituminous coal, buying from the spot market, sorry, are challenging with the milling. Please, next slide. And if you don't do any changes to the mill, you come in a conflict with the milling operation. Here's the slide, what you show the operation limit of a typical mill, and that is for a bituminous coal, and the heating value, and at the bottom the water content of the fuel is shown. For example, if you take the heating value 27,000 with a moisture of content of 0.15, so okay, you are in the white range, it's okay. But if you go to 24,000, that is a heating value for a typical subbituminous coal, then you see you're coming in the red area, and you have to change the operation of your mill. Otherwise, you don't get the results that you want for the combustion. So milling is, so you have to, if the water increase, usually the heating value will go down. And so one solution is to reduce of the separator exit temperature to bring the mill in this operation, but that is also limited. So in the next slide, I show some experience that we have in our power plant in Germany. That is a 600 megawatt unit, where due to the high volatiles and wrong operation, a mill exploded. No? So you see some pictures, some impression what happened. For example, the elevator was damaged, and here you see that is a safety gate valve what is totally damaged, and the thickness you can see that is high energy that is getting released, and that is a serious accident that might injure people what they are around there. No? So be very careful with changing the fuel. There must be some investigation to do that. So in the next slide, we had to take some measures. No, in this slide, you can see where the damages at the mill was. And there are some damages at the primary air inlet and also at the top sides of the mill. So in next slide, we take some measures, and to be safe with operation with the poor coal, to have a explosion suppression system in the mill. We installed them in the mills. When an explosion happens, this suppression system will activate it and will suppress the explosion. Okay, at the beginning we had some problem with them. They started sometimes what is not needed when it was not needed, but meanwhile we have it optimized and we have it good in operation. We can handle it. Next slide is one other case is if you buy poor coal, you have to expect that some other things are in, some metals and some bigger parts that you cannot see if you bring it to the power plant. And that is an example in our power plant in Westfalen. That was in this case, I think it was a Russian coal. So there was some metal parts in the mill, so that the mill get damaged, as you see in the pictures. So that should be avoided, and maybe you should take it in account also if you go for a poorer coal. The next slide is the measures to avoid mill explosion. So due to the time, I don't go to every point through. They are you can read it later. The major points are prevention, that is before starting to change. And if there is find some problems, then you have to find the solutions, and also you have to look at the risks and how high the risks are if you go for that. So in next slide, I will give some examples on the effect on the combustion in the by fuel change, and we continue directly to the pole 4 with a question about your experience problems caused by fuel change, if you have any. And okay, I didn't saw the poll.
Sorry, there's been a technical problem, and unfortunately we will not be able to launch the 4th poll.
Okay, good.
Yeah.
That the question was, it was interesting to know what is your experiences with the fuel change. So I will continue and give you some basic information what happens if you make a fuel change for the furnace. Next slide, please. So here you can see what happens in the combustion for different kind of coals. Here is shown the temperature increase and the intensity of the evaluation of the volatiles for different kind of coals. The drying process will be at the very beginning. That is shown if the coal is coming directly from the burner into the furnace. At 200 degrees for all of the coals, the water will be evaporated in milliseconds. And then you see the lignite, the volatile release in lignite is very high and very fast, so that it has a good ignition and start to burn very early at the burner. So you see then for the young hard coal up to anthracite and coke that the ignition temperature increases much more higher, so that also and they have lower amount of volatiles. That should be taken into account if you want to change a fuel. Mostly is from hard coal to young hard coal in your case, I think. So next slide, please. One example is changing operation models in the furnace. As Nikolaus said, there's a softening temperature, what is very important. This softening temperature shouldn't be higher as the furnace exit temperature, so that the particles are getting solid before they entering the heating surfaces. So we have an example here. We have that is a lignite, for example, a moisture with 50%. We dried it up to 12%, but we keep the impurities the same. So you see that the temperature in the furnace increases and the firing exit temperature is, let's say, higher than it should be before it's entering to heating surfaces. That happens not this extreme, but it happens if you go for from bituminous coal to subbituminous coal with higher moisture. Usually they have higher moisture, so to please take into account that this is important issue that you can operate your boiler safely. And you see some pictures, a very nice picture, but you can see that what happens if the soft ash is getting to the heating surfaces, and it will accumulate there. Next slide, please. So that is the minerals.
Sorry to interrupt. We can actually launch the fourth poll again right now. We just fixed it from the back end. Can we do that right now? You want to do it after the presentation?
We can do it after the presentation, maybe, because now
sure, no problem.
I have a few slides so that we can do it then later. Thank you.
Sure, thank you.
So please, next slide, Annie. So the minerals are the most important part, what is causing fouling and slagging. And here there's a very nice picture, let's say, what we have seen in our power plant, what is growing at the bottom and also at the top. So where the temperature is too high and let's say minerals getting soft, they will accumulate and the boiler is getting problematic to operate. And in the next slide, we can see what kind of fouling and slagging appears in which parts of the, let's say here in this case is a two-pass boiler, that it's getting from loose fouling that you can let's say clean with soot blower, and there are some bounded and some harder parts in the side at the case C, and in the very high temperature zone you get slags that is getting really hot and you have to stop the operating the plant. In the two cases C and D, you cannot clean the plant anymore. No? You have to stop the plant and clear it and clean it. No? So that should be definitely avoided, and you can avoid it also if you look at your power plant before you change the fuel. In the next slide is the solution that we found for our boiler is here to making a CFD calculations for the boiler. We had 30 boilers in our fleet, and all of them we had made a CFD calculation to optimize the operation, and very successfully. Since then, we have outage reduced dramatically. For example, on the left side, you see the that is a surface of 1,100 Celsius, the gray surface, and you see it's entering to the heating surfaces. So we changed the boiler modification and make some adaptation only by giving the data into the CFD, and we calculated the boiler again with the CFD, and on the right side you see the result that we are now make the combustion more smooth and compact, and the heat and the 1,100 surface is much more lowered below the heating surfaces. And we did it only by modeling. We didn't do any other things. The model said the burner should be looked at this size and this modification. So we built it directly over this model. We didn't make any other tests or so before. No? So the model is now very reliable, and we're using it very often. And if we make some changes, fuel change or any other changes that we need, we have a lot of challenges with emissions. We calculated with the CFD calculation. So in the next slide is a brief case. For example, what we done for a customer. Next slide, please. Next slide. For the customer in South China, they used a lot of different kind of coal, which is coming from Indonesia, from everywhere actually. No? The problem was during a very weak typhoon, suddenly the ESP broke at the exit, and there was half a meter open. No? So we get in and investigated and look what is happening. Then we find the operation of the plant is often the flue gas temperature is coming below the acid dew temperature. No? And so during the time, the metal corroded, and so due to a small wind, it get broken. In the next slide, it shows why it happens. They used, without looking and only from spot market, different kind of coals. With in this graph at the top is, sorry, I don't see the next slide. Can you, Ms. Honey, can you?
Okay, this is Sana here. We are on slide 47.
Yeah, there is, okay, there is a delay a little bit, sorry.
Okay.
The reason was that they took some coal, how it comes, and you see the moisture of the coal was between 27% and down to 17%. No? And the plant was designed at 19%. No? And so also the heating value changes. And if you have higher moisture, the acid dew temperature in the flue gas the temperature will be getting below the acid dew point, and so you have acid into the flue gas, and it damages your plant. No? So that is an effect what is not directly at the boiler, that is at the backpass, and if you go below acid dew point, you will destroy your whole flue gas chain. No? So that is actually what I want to give you as an example. Next slide, please. That what can happen if you don't look very early to your system and making investigation. What is the effect of using poorer coal that you have, or it's or what is designed for? So thank you very much for your attention, and I give back to the organization.
So we'll quickly launch the fourth poll right now.
We can do that. Yeah, we can do it.
Yeah, which is your experience with problems caused by fuel change. Just a moment.
Yeah, I think here multiple answer makes no sense here, I think. Yeah, maybe for the engineers that they have massive problems is such highly recommended to look at their system and to check with experts to see if their plant is still running in range, to making a heat and balance calculation for the plant, and maybe actually some of the causes can be solved very easily. But others, if it's permanently, then have to look for some maybe hardware solution also. So thank you.
Thank you, Dr. von Bargen, as well as Mr. Meschgbiz, for a very insightful session today. We have many raised hands. Dear participants, if you want to ask a question, do leave your questions in the chat box below, and we will be answering your questions. In the meantime, gentlemen, we have already many questions, and I'll start with one right now. It says, with greenhouse emission concerns around, do you think coal lignites still play a role for direct burning? I'll leave it up to you to answer.
I think I'll answer that. I think it will still have a role. It's going to be eventually a diminishing role, but the reason why coal is burned in the first place is because actually it's a fuel that's readily available, and it's comparatively easy to burn and generate electricity from it. And you can produce as much of it as you need. That is, power plants have turned on capability, and you can have some power plants going into a different load regime, so maybe operate only in mid-merit or something like that. So while we still have the renewables being built up and solutions being worked out for bridging the non-production times that the renewables often have, the wind and photovoltaic, we'll still see quite a significant role for coal. I mean, whether that's nice or not, desirable is another question, but I think the reality of the situation is such that the renewables are only coming into play now progressively more in the next 20 years. And that's why also, for example, RWE has said we'll be greenhouse gas emission free by 2040. That's 20 years from now, not day after tomorrow, simply because there's so much that needs to be done.
I think in the rich countries there is this effect with going to renewables, but many countries, developing countries, they have to use coal, and if they have lignite, that's the cheapest coal that they have. And I don't think that is going so far away from the production lignite as it expected, unfortunately.
Yeah.
Thank you to both of you. I hope that answers your questions. The next question that we have from the participant is, how is the performance when coal is gasified?
Axel, do you want to answer that?
Yeah, you can gasify the coal. The technology is available, and there are different kind of gasifier technology, but it's not commercial for operation.
Yes, it's just very expensive as a complex technology.
Mm-hmm. And you can produce energy, and you can produce syngas, you can do a lot of things with IGCC, but that is not at the moment economically. That's the reason that there are few plants in operation, and we had also operated some of the plants, but now we switched them off. Also in Europe, there were some plants in operation. They are not working anymore.
Is Bochum out as well?
Oh, sorry?
Is Bochum also out of operation now?
Yes, Bochum is out, yeah, in Netherlands, yeah.
Okay. Yeah. Yeah, the thing is, it's the greenhouse gas and the slightly better efficiency that you get, you know, comes at a quite high capex, and probably you'd be better off directly putting that extra capex into the money into renewables and simply displacing coal production or generating simply by having actually renewables in there. That would probably be overall the more economical solution.
Okay, so to summarize, it is possible, and there is a slight improvement in performance when coal is gasified, but currently the cost is too high at the moment.
Yes, and the greenhouse gas emission reduction that you get is sort of incremental rather than fundamental, and that's why it's probably better to look at other things, and as I said, putting up the same money in wind turbines and then let the coal-fired power plant only run when you need it.
All right, thank you. So we'll move on to the next question then. How much the plant estimated coal quality contribute to the overall power plant efficiency, especially when power plant is a CFB boiler, lignite coal being fed to PP?
I think, Axel, that's one for you.
Yeah. The coal quality has a big impact on the efficiency. Not on the efficiency of the power plant, it is on the efficiency of the coal heating value, what's coming in and what is the power that's coming out. And if you change the coal quality for lignite with the moisture, if it's getting higher or lower, the CFB can combust it very well, that it can handle it, it's no problem, but you need much more coal input, and it increases your cost for the operation. And let's say the conversion ratio from heating value coal to the power output getting worse.
All right. Thank you, sir.
For lignite is in a given deposit. However, for example, ash and moisture are negatively correlated with each other, and so the effect of moisture that they have on the plant will be offset by the effect of ash. The two counteract somewhat, but in general, yes, the thing is, worse coal means worse, poorer performance of the power plant.
Thank you. Yes, so you mentioned about CFD output, so maybe this question would be a good entry point for it. What is the CFD output when you improve the boiler operation?
Yeah, the CFD output. This CFD, what we do, it's a 3D CFD, and it will calculate. It has about 30 million cells in the boiler itself, and you give the parameter, the geometry and the operation parameter, what is coming into the boiler, and the exit, it's looking up to the economizer, and it gives you information at every point in the furnace about the gas concentrations and also the heat release in the boiler, where the heat will be released. And as you saw about the temperature profile in the boiler, you can make oxygen profile, CO profile, and you can look where part of the plant is high CO and high temperature CO, which is corroding your heating surfaces in the boiler. And also you can bring the power plant operation, the combustion, into the shape that is fitting for this plant. And as I show in the picture, that was one example only for the temperature. We use it, and we can walk through into the boiler and visualize and look where the particles are, how they are flying, and where is the recirculation, and where are the temperature too high, so we can directly see what we should do to avoid these changes, negative changes, let's say. And it is not complicated. We need only the data from the boiler to adjust the model, and then we can start with the first run, the design, and maybe the coal, what is designed and what's the coal today. And we see very, very fast what is the changes happening into the boiler and what we should do. That is one example.
All right. Thank you, sir. Next question that we have, a lot of questions have come in. It comes really fast, actually. So yeah, this is the participancy is really engaging in this particular webinar, and we love it. We love to see more questions, please. So just leave your questions in the chat box. The next question is, what is the industrial practice for the estimation of coal quality, either at mine or power plant for commercial purposes?
Well, basically,
that's your part.
Yeah, my part, yeah, that's definitely. It's basically sampling it correctly and analyzing it at the laboratory. The most important part is the correct sampling. Lots of things one can do wrong, especially when sampling, for example, from stationary stockpiles or things like that. That makes it particularly difficult. As I said, it depends also on whether the coal comes from a homogeneous source or whether the coal comes from actually as a blend from, for example, several seams, coal seams with different characteristics. Then what happens to the coal before it reaches the gate of the power plant is actually very important and needs to be taken into account into the design of the sampling system and sampling strategy. For the high moisture lignites in particular, the analysis and what happens to the samples is important as well. So one correctly analyzes them and doesn't get errors on things like the total moisture content because samples dry quite easily. So one has to keep an eye on that. But the most important part is the correct sampling strategy and the correct sampling method for the specific situation. There's no one solution that fits all. Some principles, but it needs a close look at it. But that would be then producing a reliable result.
Thank you, sir. The next question is, someone wants to know whether you would recommend mixing good quality coal with bad quality coal, and will that lead to any problem in the process?
Axel, I think that's
yeah.
Yeah.
Actually, mixing a good coal is all the time a good idea, but it depends on how the coal's getting in competition due to the during the ignition and in the burner. If some coals they have much more high calorific, much more high volatiles, they will ignite earlier and take the oxygen away from the other coal. So the other coal has then a longer time for burning, and it could be that the burnout will increase. And sometimes, that is not often, seldom, mixing coal can build a eutectica, and this eutectica can bring the softening point of the ash very low, so that you have due to the eutectica higher fouling and slagging in the boiler. But that is not so often, but more the uncontrolled combustion could be a problem. But usually in a small amount, adding some coal is no problem, but maybe you have to make the test. So that is, you cannot see it by generally for every coal. No?
Yeah, the important thing is also that when you're actually starting to mix coals, it's important to ensure that you get a very homogeneous mix that you feed to the boiler, so that you will have in any given time when you're feeding in, you're coming in with about the same mix of the poorer quality coal particles and the better quality coal particles. So you've got actually a steady behavior of the mixture. If it's poorly mixed, then you'll get forever changing composition, which causes problems and instability. Sometimes people also, let's say, put specific coals through specific burners. Can be done, depends on the characteristics of the coal, but you usually limit it to specific ratios that you can use, and your geometry of where your burners are may not always be conducive to doing something like that.
All right, thank you for that comprehensive answer, I think. The next question is that how do you modulate SADC during abrupt change in coal quality?
What is an SADC?
I'm not familiar with SADC.
Okay, then we'll take it offline for that. We'll answer you through email, perhaps. Yeah. We'll move on to the next question. What is the impact of coal quality on boiler tube leakage?
That is if the coal is not burning well and it's not fitting to the plant, you produce a lot of CO. What can produce corrosion at the tubes, and it's getting after a while leakage. The second is over temperature at some parts. What is the furnace ball is not homogeneous, and some area of the heating wall are too high. The third thing is acidic components in the plant. For example, with high chlorine in the fuel, that may cause also corrosion at the walls and causes to the tube leakage. And usually, the most part of this mostly are these effects. And one effect can happen is that if you have a fuel with a very sharp ash, that is usually at the lignite power plants, that can cause erosion in the tubes. And so after a while, the tubes getting leakage by erosion. That are the major points what you can get tube leakage.
Thank you, Mr. Axel. We'll move on to the next question. SADC is secondary air dampener control. Would you like to be able to answer?
For which plant? For CFB or for PC boiler?
Yeah, so that is not mentioned. So probably we'll take it again offline.
Secondary air. Yeah, that is, I think, for PC boiler. Okay, what was the question again, please? Can you switch the question?
How do we modulate SADC during abrupt change in coal quality?
Sorry, I cannot answer that.
Okay, not a problem.
It's not. It's too general, actually. I don't know what is the question.
So yeah, so we'll get in touch with you again, dear participants,
yes,
to be more specific, and always we'll get in touch with you and get you the response you need. In the meantime, we'll move to the next one. Is there any reconciliation method to delineate the deviation of coal quality being fed to the power plant? And can we track if the actual issue of the coal quality of the fed coal or power plant efficiency? So essentially, he wants to know whether is there a reconciliation method to delineate deviation of coal quality versus power plant efficiency, and how can you track it?
Yeah, there is. Actually, you have to know which coal is coming into your power plant. If you're buying bituminous coal from a ship, you have one analyze, and that's it. And if you want to monitor your efficiency of your power plant by the coal quality what's coming in, then you have to make often sampling and analyzing the coal and recalculating it to the power output. Then you see what is the effect on your efficiency.
Yeah, the effect on the coal composition on the efficiency is something that you need to establish with your plant with certain specific tests, because each plant behaves differently, where you sample your coal intensively and you monitor very closely what your power plant is doing as you're feeding it. But when it comes to actually reconciliation, yeah, that needs to be based on intensive sampling. For tracking online analysis or tracking of ash content or something, I will give you a little bit an idea of the variation of the coal quality so that you can react to it or you have a correlation there. But for absolute values, it's you do need actually the analysis.
All right, thank you, sir. We are actually on time. We have around a few more questions actually. Would you mind extending the time, or is it to answer those questions?
Yeah, we have time. Or I have time.
Okay.
No, we have no time.
Okay, so we'll go to the next question is, how much percentage of loose biomass of 6 millimeter can you mix with lignite in CFBC?
Yes, 6 millimeter, that is quite long actually. The question is what kind of biomass it is. If it's straw or if it's some grasses or wood, it makes difference in the combustion. Let's say 10% adding biomass to any power plants, PF or CFB, is not a problem. No? That the power plant can handle it. No? But if the particle size is too large and the biomass is not burning so fast, because biomass needs a higher residence time in combustion than coal. It ignites quite fast, but it has a stable structure. So in the CFB, if you have too long biomass and they are getting light, they will be separated in the cyclone, and then they will stick maybe somewhere in the heating surfaces, what is not recommended or not wished. So it should be this size that you'll be ensure that the biomass will be circulated in the CFB, or that is so burning, so fine that is burned until the entering the cyclone, so that not too much biomass is getting out of the system unburned.
The other aspect on limiting how much biomass you can co-fire will depend also, of course, on the characteristics of the ash from the biomass. Sometimes you have some, let's say, some rather undesirable compounds or elements coming in with the biomass, and so you have to look at your fouling and slagging characteristics as well, especially in the combination of biomass with the coal.
Yeah, but that is independent of the size. You have it anyway,
yeah.
no?
Yeah.
That is an ash issue, no?
Yeah, but that is an issue that one needs to consider along with it. It's not just the size issue, how much you can co-fire that, but you also have to look at the ash, for example.
Okay, thank you so much. We'll move on to the last two questions. First one would be, what is the recommended method of coal blending to fire constant GCV coal?
That depends on coal blending. I mean, it depends on where your coal is coming from. Of course, you're trying to go for constant calorific value, and I guess from the question that this is sort of in the hard coal world where we have been dealing with high moisture coals. But it very much depends on what you have. Ideally, you would be doing it on the stockpile, and or even better, you have two separate stockpiles or three different stockpiles with reclaiming equipment for the different types of coal, and you can just adjust the ratio of the coal being fed to the boiler by reclaiming from different coal types simultaneously at specified rates. You know, you adjust just the speed of the reclaiming wheel, so that on the belt where you collect all that, you get a constant ratio of the different coals that you're putting together. That's the best blend you can get. The problem is that often you're in a situation where you don't have the luxury of having a storage coal yard where you have the ability to store three different kinds of coal, let's say, and reclaim from each of them independently or simultaneously. That yeah, and then it becomes more difficult. Then you have to look at stacking sequences, reclaiming sequences, and how you get your whether you get your things by coal, by train or by ship or whatever. So it becomes then quite complex, especially when space is scarce.
Right, thank you. And the last question that we have from our participants today is there a relation between high moisture in coal and the chance of explosion in a boiler?
Axel, I think that's for you.
Yeah. Actually, if I say in an easy word, in boiler explode nothing. It's only boiler explodes. The explosion in the boiler happens only if you, let's say, turn off the boiler and some gases are in or some dusts without flame, and you ignite again. Then you have a mixture what explodes. Otherwise, the explosion is during, as long as a flame is available, there is not an explosion in this form. There are some cases that there were a lot of coal and ashes, unburned carbon in the boiler, and suddenly they release and fall down, and you have a lot of fuel. But that is, yeah, that is a pressure increase, but we cannot say it's explosion. Usually explosion happens only during, yeah, let's say start up and shut down.
Yeah, and usually the coal explosions happen outside the boiler. I mean, typically in the mills or in the feed bins or something like that, where coal is sitting behind and getting dry, and then you might, you end up having coal whirled up, dry coal whirled up and then ignited. That's more likely where you're going to get it, an explosion.
So as long as you have a flame into the boiler, it's very unlikely to have an explosion. The explosion happens often in the mills, and it's coming over pressure into the boiler, and the flaps can be opened, and so that is the most part, and especially in the PF boiler, the pulverized fuel boilers, we can see that.
Yeah, the question contained a second part was, is moisture is high? So we're talking about probably going to lignites. Basically, these coals will tend to self-ignite anyway. That's, you have to know what you're doing to keep an eye on it. It's not like they explode straight in your face, but typically when you don't keep an eye on them. So that is something at lignite-fired power plants. The dust smoldering or dust, self-ignition of the coal and possible dust explosion, typically outside the boiler. They are actually an issue, typically kept best controlled with good housekeeping.
Right. Thank you to Dr. von Bargen and Mr. Meschgbiz for the very insightful answers to all these questions. Yeah, we have the questions are still coming, and I think we will be taking that off and follow up through the email as well. And that concludes our Q&A. And let me just close by thanking both of you, Dr. von Bargen and Mr. Meschgbiz, for taking the time today, joining us all the way from Germany. And it's very insightful information on how to manage coal and how to operate it, and mixing coal, whether we should mix coal or not, etc. And it's very wonderful to have both of you here today with your expertise. And for participants who wish to get in touch with both of them, their contact information you can view on your screen. And if you have further questions, do email us as well. It will be shared with you after the conclusion of this webinar. Like all of our webinar, the recorded link of this webinar along with the presentation will be shared with you in a few days, so don't worry. And yeah, thank you all of you who are here today for your participation, for your active participations and your engaging questions. And thank you to both our speakers. Thank you so much. And yes, we will see you soon. Have a wonderful day. Thank you.
So thank you very much also from my side.
Yeah, and well, have a good day.
Thank you, sir. Thank you.
Bye-bye.
Bye-bye.